Now we're going to look at the nuclear atom. This is what the atom looks like. This is how it can be represented. It basically has a nucleus which has neutrons and protons. These collectively are called the nucleons because they exist in the nucleus, and around the outside we have the electrons. Between the nucleus and the electrons there is a huge amount of space. This is also known as the Rutherford atom, after the professor that basically came up with this model. It wasn't always believed to be like this. This is the model, which is called the plum pudding model. And what they believed is that the atom was like a doughy substance, where the positive was basically the dough, and the negative stuff was these currents. They knew the electrons could be taken away from the atom, so they thought they were these detachable currents, but the positive part was very doughy there. So that's the electrons, and most of the atom was made of this doughy positive charge. But then they did an experiment. Rutherford organized Geiger and Marsden to fire helium nuclei, which were very compact positive charges, at a thin gold leaf. And what they expected to happen was that, since most of the atom was got this doughy positive charge, for these other particles to fly through the atom without being disturbed. But what did actually happen? Well, what did actually happen was that most of the other particles did fly through, but some bounced back. Now this wasn't expected. And the reason they bounced back is they almost collided with the nucleus, which was also very compact positive charge. So they've basically found out that instead of all the atom being a diffuse positive charge, the positive charge was compacted right in the center, and most of the atom was space. This is an illustration of this.
The nucleus of an atom was first discovered when a beam of positively charged particles emitted from a radioactive source was aimed at a fluorescent screen. The particles caused the fluorescent screen to glow. When a very thin sheet of gold foil was placed in the pathway of the particle beam, a few particles were deflected to the side. Occasionally, particles were deflected straight back. But nearly all particles passed right through the gold foil, as if it were not there. The scientists concluded that atoms must be mostly empty space, and that because some particles are deflected, there must be a small positively charged central mass, which they called the nucleus.
So, the first observation was that nearly all the other particles went through without deviating. The second observation was that some particles were actually deflected by a really large amount, and so they almost kind of bounced back. It was a bit like firing a bullet at a pillow and having the bullet bounce back from the pillow. It was just not expected. Now, how can you explain that the other particles went through without deviating? What can you explain that? Most of the atom is made of space. The second one is some particles were deflected considerably and even bounced back. So what could be an explanation for that? That the positive charge is basically concentrated in a very dense, compact nucleus.